Welcome to Timeless with Vivek Nittoor. Our guest is Professor Juzer M. Vasi. Professor Juzer M. Vasi is Professor Emeritus at the Department of Electrical Engineering at IIT Bombay. His research interests include silicon photovoltaic devices, reliability of solar modules, photovoltaic deployment in India and globally, and nanoelectronics. Professor Vasi has been Deputy Director at IIT Bombay. Professor Vasi earned a B.Tech in Electrical Engineering from IIT Bombay in 1969 and Ph.D. in Electrical Engineering from the Johns Hopkins University in 1973. I have been a student of Professor Vasi at IIT Bombay and hence very excited about him being our guest today. Good afternoon, Professor. How have you been?
Hi, Vivek. Good afternoon. I've been well. Seeing you also after quite a long time. Hope you have been well too.
Absolutely, sir. Thank you very much. Sir, how have your memories of H2 and experiences of having been a B.Tech student at IIT Bombay been?
Well, of course, being a student at IIT Bombay has its own special experiences, and I guess we've all of us who have spent a lot of time at IIT have very special memories. Of course, in my case, I had spent 5 years, 1 year more than many of you. So that's even more memories of Hostel 2 and of IIT Bombay than some of you have. I must mention though that this was very long ago. I was a B.Tech student here in 64 to 69, which is really in the very early years of IIT Bombay. So obviously it was a bit different then than what it is now, and probably what many of you also have gone through.
Sir, how was the campus different in the 1960s?
Well, the first thing, of course, I would say by memory of the campus then is that it was nowhere near as green as it is today. So many of the trees and all which you see on campus today were really planted in the early years and came up along the way. The other thing about the campus then is that it was, really a remote place out in the wilderness somewhere, which is very different from what it is today. It's right in the middle of the city, so to speak. But in those days, to get to IIT was not easy. There were a few buses plying from Vikhroli station, and if you didn't get one of those buses, you would have to walk up to IIT. Autos and all were very infrequent in those days.
I'm amazed to hear that, sir, because I am unable to imagine the IIT campus, without greenery. Which means that there was a time when greenery, as we know it, on the IIT campus did not exist. So this is news to me.
Yes, that's surprising to many people. Of course, I must admit, however, that when the monsoons came, obviously the hills, which you're very familiar with, would turn green, which they still do today. But a lot of the vegetation, trees on campus really did not exist, at least to the same extent that it does today.
Sir, what was your childhood like and what were the key influences on you at that stage of life?
It's a difficult question. My childhood was very, very uneventful, I would say. It was just a happy time with family and friends. We used to, of course, have a lot of fun in school, but also around where we lived. A lot of kids were there. We used to play all the time. And then with family and relatives, always something going on, go out and so on. So uneventful, but happy.
That's great to hear, sir. Sir, how did your interest in microelectronics originate? Did it happen during your undergraduate studies or did it happen during your graduate education at Johns Hopkins University?
Well, it definitely started during my undergraduate years. I must also tell you that before I joined IIT, when we were in high school, I always did like playing with various electrical gadgets. making little electromagnets and so on. Very different, of course, from the kind of hobby electronics which people do today. But in those years, I was interested in that. So that's why when it came to IIT, going to IIT, I chose electrical engineering. And of course, I mean, I'm glad I did, because it was not then the most, what shall I say, the most highly sought after branch. Mechanical was then the most highly sought after. But because of this interest in electricity, I chose electrical engineering. And of course, as I said, I'm glad I did. But as we moved on in the fourth year and the fifth year, we had a couple of courses on semiconductors and semiconductor materials and semiconductor electronics. And I found those very interesting. And that's when I kind of decided that that's what I would like to work further on. Of course, you must remember that this was the late 60s, where semiconductors were still, starting to come up. For example, our courses in electronics, which we had during our third and fourth years, really had quite a lot of material on vacuum tubes. Semiconductor devices, transistors were starting to be introduced, but still a lot of material using vacuum tubes. So electronics using vacuum tubes is what we learned quite a bit of.
Understood. Sir, what have been the key influences on you, starting from school, IIT Bombay, and at the Johns Hopkins University? Which professors and researchers influenced you the most, sir?
Well, of course, there were a lot of influences naturally, not only technically, but also in many other ways. Probably I would say the other ways are as important as the technical influence. In school, of course, we had the standard subjects, physics and chemistry and maths. All of them were very interesting. I liked all of them. But I also liked, we also had history and geography and literature, and I actually liked those equally well. I think in high school, probably one of the teachers I remember best is really our English teacher, who used to, of course, teach us not only literature, but also language and, how one must speak and what one should say and, how to say it. And also, for example, he really evoked in many of us the love for reading, because he would ask us every week, which book have you read during the last week? And we were supposed to tell him which book we read. So that was high school. Coming to IIT, of course, as all of you would have seen, a lot of influence from one's friends and so on, which was actually both high school as well as IIT. I must say one thing which I really got exposed to is a whole variety of people, different types of people, different communities, different backgrounds. And, I think it was so easy to think that this is really what India is, an amalgam of so many types of people. Particularly, of course, Mumbai, Bombay as it was then, because you did come across very, very different and many, many different types of people. Coming back to IIT, I would say, of course, many of the instructors influenced us. I must say that, we had some wonderful instructors. Really, IIT in those days, perhaps today also, was the level of teaching, the interest which the teachers had in what they taught and how they taught us was tremendous. So we had many fantastic teachers. I'll just mention one of them. One of them was Professor J.R. Jimmy Isaac, and he taught us digital electronics, and he really made that course very, very interesting. I think he almost never prepared for any of his lectures. And that's partly perhaps what made it so exciting. In fact, I used to, when I was teaching also, I used to somehow tell myself that, don't over prepare for a lecture, because then it becomes, too boring for the others. Whereas if you are also struggling sometimes or suddenly thinking of a new idea as you are talking, which Professor Isaac used to do, that makes it very interesting for the students. Anyway, digital electronics, and we, of course, that particular course, we used a lot of transistors also. That again stoked my interest in semiconductors. And of course, digital electronics was one of the first applications of really microelectronics.
So Professor Isaac taught us the first course in programming, CS 101.
Yes, of course, that's right,
Yes.
because
Yes.
he then moved over from electrical to the computer science department. And I'm sure many people remember him as really very charismatic teacher, also quite well known for his, what shall I say, unpreparedness. I'm not sure whether he actually was unprepared or it was only a show which he made to keep us all interested and excited to see what he's going to be up to next.
Sir, how was your stay at the Johns Hopkins University?
Well, that again was definitely an eye-opener because, a completely different environment. This is 1969, so really way back when foreign students were not that common. Pretty common, but not, I think, as common as today. And surely the Indian community in the US was really quite small then. In terms of the technical aspects, of course, that's really where I learned to do research. And obviously, one of my main influences was my PhD advisor. He was Professor Roger Westgate. He was a young professor then, I think, probably had been an assistant professor for 5 or 6 years when I joined. So not too much of a difference in our age, only maybe 10 years or so. In fact, he still continues to be quite active. But he taught me quite a few things, not only obviously the technical aspects about semiconductors and so on, but many other things about how to do research. He was also an avid bicyclist. I used to ride my bicycle quite a lot when I was there. So we used to always talk about bicycling. This is, the early 70s. Cycling in the US was very, very uncommon then. And people who would see you on a bike, would often stop to ask what you were doing, whether you could not afford a car, and where were you going. And sometimes, of course, they would also hurl abuses at you. So it was sort of the Wild West of bicycling in those early days.
Sir, has your interest in bicycling continued?
No, I'm sorry to say it has not. I continued it when after I came back from the US, I joined IIT Delhi initially, where I did again have my bike. Of course, it was a 10-speed bike, again, very unusual in those early days. And I did a lot of bicycling around Delhi because Delhi in winter is really an ideal time for cycling. So I used to go to all over Delhi, and it has so many beautiful monuments. So all of those I used to visit. But after joining IIT Bombay, I did not really continue, except, of course, simply as a method of commuting from home to the department.
I understand, sir. Sir, going back to the year 1973, when you completed your PhD, the electronics industry was taking off in the US in a very big way. So you returned to India after your PhD, as you mentioned earlier, to take up a position at IIT Delhi. What were the main reasons for your return back to India, sir?
Well, first of all, Vivek, let me just mention that after I finished my PhD, which was in the summer of '73, I did get an offer to continue at the Johns Hopkins University as a visiting assistant professor. So I took that up for a year. So I was there for a year. I taught a couple of courses, continued on my research, and then it was in the summer of '74 that I started coming back. Interestingly, what I did on my way back is I had a lot of interest uh, in ancient American architecture. So, I spent almost 3 months or 4 months traveling in Mexico and Bolivia, Peru, all of these places before coming back. Finally landed back in India in late 1974. And that's when I joined IIT Delhi. I had received an offer from IIT Delhi and IIT Kanpur also, but I decided to join IIT Delhi and joined IIT Delhi in December of 1974.
So I'm surprised to hear about your interest in the Mayan and the Aztec culture, and your visits to the various important sites connected to those civilizations. Would you like to talk a little bit about that?
Well, it was, yeah, a very interesting reason, I think, for this to happen. And that is, in high school, we had a geography teacher who was actually from Peru.
Right.
And he used to tell us a lot about the Inca uh, architecture and, of course, the famous Machu Picchu, very famous today. In those years, not
Right.
many people knew about it. So he always used to tell us, you must visit Machu Picchu once in your lifetime. So after that, I used to read quite a lot about Inca, but also then the Mayan, Aztec
Right.
uh, uh, um, architecture. So I thought, anyways, I'm there in America before heading back to India. God knows when I'll be back in this part of the world again. Let me do what Mr. Zavala, that's the name of that Peruvian teacher we had, what
Right.
Mr. Zavala told us, go and see Machu Picchu.
So, how was your experience of seeing Machu Picchu for the first time? Because I've heard a lot about it, even though I've never been there.
Yeah, it is, I guess, still a really amazing place. Way up in the mountains of Peru with two very dramatic mountains out there. And of course, not only the environment, but even what they could build there was quite amazing, is quite amazing. Huge stones, how did they move them there, etc., etc. But, even the Mayan temples, which I saw both in Mexico, but also in the other places like Honduras and Guatemala and so on, they are also quite amazing.
Are there any
Anyway,
commonalities in the architecture between these two cultures, or are they completely different?
they are quite different, really.
Okay.
This is too much of a digression from microelectronics, Vivek.
I understand. Sir, which of the projects done during your professional career have been closest to your heart? Could you please tell our viewers about this project and the challenges involved?
Yeah, sure. There have been several projects. I'll just mention very briefly that when I joined IIT Delhi, which was in late 1974, there was a group led by Professor Bhattacharya there, which was just starting to work on MOS devices, metal oxide semiconductor. In 1974, MOS was still, a baby technology. Bipolar was really where a lot of real activity was taking place. No, people even doubted whether MOS could ever really beat bipolar. But I got involved with MOS, which of course turned out to be the right choice. So that's when I first got involved with MOS, and in particular, we had a nice project working on charge coupled devices, CCDs. One of the earliest CCDs, and we made actually some CCDs at IIT Delhi. When I moved to IIT Bombay, which was in 1981, I of course continued my interest in MOS. By that time, of course, CMOS had started becoming important. So we started looking at CMOS. And a lot of my initial work, of course, was looking at CMOS, various aspects of CMOS, but the devices really, the reliability of the devices, the structure of the devices, later on the scaling of the devices. We had a couple of projects. One of them was a so-called microelectronics project through which we could build up the lab here. Later on, of course, we had the nanoelectronics project, which Professor Ram Gopal Rao was again heading when he was here. But a lot of activities really related to MOS, CMOS, and generally speaking, microelectronics and nanoelectronics. There were several interesting projects there. Maybe I won't talk too much about the details of these projects. One of the general areas I was really involved with throughout these years is the reliability of MOS. That was a big problem because the oxides were very thin. They were susceptible to all kinds of damage, hot carrier damage and radiation damage. So we did a lot of work trying to understand why the degradation takes place, and also later to try and solve the problems of this degradation. One very interesting activity which arose out of the nanoelectronics project was something called the Indian Nanoelectronics Users Activity. That's in Indian Nanoelectronics Users Program, INUP is what we called it. The reason this was interesting is that, we had built up very good facilities for microelectronics and nanoelectronics. And we really had a kind of a commitment that once we set up the facilities, we would actually open up these facilities to users all over the country. And the reason obviously is that these are expensive facilities. You cannot really replicate these facilities at many places. So what we were told, and this was told to us by Dr. Chidambaram, who was the principal scientific advisor to the government of India for many years, for I think about 12 years or so. What he requested us is that, look, if we fund you for the nanoelectronics, you must eventually make sure that it's available to other users as well. So that was the genesis of this Indian Nanoelectronics Users Program. And it was really a tremendously successful program because we could put into operation a whole mechanism to get PhD students from other universities, other institutes to come over here, use the facilities at no cost to them. All our equipment could be booked online, so they could plan out their process, book equipment online. We would pay them their travel to come here. We would provide them accommodation either on campus, or we had rented out some flats where they could stay. So they had really nothing to worry about except to get their chips or devices working. Also, we arranged that the intellectual property really belongs to them. We are providing the facility, but the ideas are theirs. So it goes into their thesis, into their papers, and the IP is fully owned by them. So through this very successful INUP, which still continues, by the way, we really have had, literally thousands of people who have attended, who've come to IIT Bombay and attended, and I think over 500 projects have been done using these facilities.
This is really great to hear that IIT Bombay has contributed so immensely to the scientific and technological ecosystem in our country. This is really great to hear.
Yeah, and this was very, very gratifying for us also, to be able to help students not only within IIT Bombay, but really across the country.
Sir, would you like to talk about the Dandi Memorial Project and the challenges involved in realizing that project?
Yeah, sure. This was a very interesting project. But maybe before that, Vivek, I will just briefly mention that, how I made a transition from microelectronics to my current interest, which is photovoltaics. So, in a sense, this happened just after the time that I was a deputy director. So I continued, even while I was deputy director, of course, I continued my interest in microelectronics and nanoelectronics. But around this time, it was becoming kind of apparent to me that there's not that much which I could contribute, or even that India can contribute, because microelectronics and nanoelectronics has progressed so rapidly, and the kinds of technologies which people are looking at, it's more and more difficult because so intense, so equipment and capital intensive, that it's not easy really to set up those facilities in India. And Moore's law was still important, trying to shrink all the time. I remember waking up some morning and saying, am I going to spend the rest of my life trying to shrink these CMOS devices? So, anyway, there was this kind of an existential question which was coming up in my mind, but I didn't know what to do about it. What happened, however, is that Dr. Chidambaram, the same Dr. Chidambaram who had told us to do INUP, one day he called me and requested us that, look, photovoltaics is going to become important because we are going to launch the National Jawaharlal Nehru National Solar Mission. So with your experience, your meaning IIT Bombay's experience in semiconductors, and also you have a very good energy department, why don't you take up photovoltaics? So this was an interesting thought. By the way, I always thought photovoltaics, I used to teach it in my physical electronics or semiconductor device course. It's a simple PN junction. There's nothing more to it than a PN junction on which you shine light. Of course, I've learned very much more than that. It's really a very interesting device. But anyway, I said, okay, possible, but none of us is really that involved with photovoltaics. But then I talked to a few people. I talked to Professor Khakkar, had just taken over as the director then. And we decided, yes, let's go into photovoltaics in a big way, even though we didn't have that much experience, but we felt that we could definitely do it. And it in any way solved my existential problem also, because solar energy is so obviously important for India. It's we are blessed with abundant solar radiation. Also, especially in those years, the grid did not penetrate everywhere, so it was a very good way to get off-grid solar off-grid power to places which otherwise could not have electricity. So in all of these ways, it seemed really the right thing to do for India. So I got involved with that, and the more and more involved I got, the clearer it became to me that solar energy is really the thing for India, and photovoltaics is really the backbone of solar energy.
That's great to hear. In fact, it's very fascinating to hear about your transition from microelectronics to photovoltaic research. And one question I had was, isn't Moore's law common to both these areas?
It is in a way, especially when one looks at Moore's law in terms of the cost. That is, how rapidly has the cost of transistors reduced. And there has been a sort of Moore's law in photovoltaics as well, where the cost of the solar cells, the solar modules, has decreased dramatically over the last 10 years or so, 15 years, but not as dramatically as Moore's law. So it does exist in a way for photovoltaics, but not to the same extent, and obviously not to the same, not with the same effect which it has had for microelectronics. But Vivek, anyway, what happened then with Dr. Chidambaram's kind of encouragement, we set up the National Center for Photovoltaic Research and Education at IIT Bombay. So it's really the major photovoltaics research and education entity in India today. And over the last about 9 to 10 years, I would say we've been doing a lot of very interesting work in photovoltaics. One of the things has been, which I've been personally involved with, is the photovoltaic module reliability, the reliability of solar modules, how they are performing in India.
Right. Sir, I wanted to ask you again about the Dandi Memorial Project.
Yeah, Vivek, that was also a very interesting event, because what happened is a couple of years after we started the National Center for Photovoltaic Research and Education, Mr. Gopal Krishna Gandhi, who he had just taken over as chairman of something called the High Level Dandi Memorial Committee. And what his idea was that we'll set up, that there was a process on to set up the memorial at Dandi. Of course, as you know very well, Dandi was the culmination point of the famous Salt March. This very, very important event in our independence movement really has not been, I think, it has not been has not received the kind of, publicity which I think it should have. And certainly Dandi, where this famous picking up of the salt took place, that really it is unknown to most people, though most people don't even know it, or at least did not know then where it is. So there was a plan to set up a memorial there, and what Mr. Gandhi's idea was that the memorial should be really powered by solar energy. So knowing of our center, incidentally, Dr. Chidambaram plays again one more role here, because when Mr. Gandhi asked Dr. Chidambaram, can you tell me who can really help in setting up a solar energy power for the Dandi Memorial, Dr. Chidambaram again suggested our name. So when Mr. Gandhi called me and asked whether, we would help in setting up the memorial, my first reaction was, of course, yes, we would really be honored to do it. But before I actually said yes, I thought we should take the permission from IIT to really get involved in a major project like this. Professor Khakkar, who was, of course, the director then, was very, very encouraging. So he said, yes, let's definitely go ahead. So we started off, we went to Dandi, we met Mr. Gandhi there, and then we started doing various things. We started off really by looking at mainly the solar energy part. But as a consequence, what happened is that, for setting up the whole memorial, gradually as time progressed, we have, of course, as you know quite well, the Industrial Design Center, where they have a lot of activities in art, sculpture, and so on, architecture as well. So I had gone actually to Dandi initially with one of the persons from IDC, plus together Professor Kirti Trivedi, and also one of the solar energy persons, Professor Chetan Solanki. Three of us had gone. And what it appeared to us is that not only could we get involved with the solar energy, but some of the other aspects as well. So in fact, as things progress further, the Dandi, the high-level Dandi Memorial Committee actually asked IIT to get more involved even with the art components and the architecture components. And eventually they appointed us as the uh, 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 what did they call it? The overall implementing agency for the Dandi Memorial Project. So we got more involved. The Industrial Design Center got involved, but eventually, as you know, we had to start looking at various aspects of civil engineering. We had people from the civil engineering department involved. We had people from the material science department coming in. Of course, the solar energy and electrical engineering people were there. We also had people from the environmental science, the geotextile people, and finally, all of the inputs coming in from different departments of IIT really contributed to the design of the Dandi Memorial. It was finally put together, implemented by the CPWD through an architect which we had chosen from IIT Bombay. So it was really an interesting project where many of the departments of IIT all contributed towards really making of a major national monument.
So could you please talk about the solar facility that's there in the Dandi Memorial Project, sir?
Yes, so this was also very interesting because what our Industrial Design Center felt is that instead of just having solar modules like you see in many places, we should really have an aesthetic version of the solar modules. So what we did, mainly done by the Industrial Design Center, is to really design solar, what we are calling solar trees. So each solar tree has 10 or 12 solar modules which are put up, and there are about 20 of these trees out there. So there are a lot of solar modules, and the amount of energy which is being generated is, Dandi is now a zero net energy site, which means that it generates as much energy as it consumes. Of course, it does draw power from the grid, but it also exports power back to the grid, making it a net zero energy site.
It's great to hear that it is a net zero energy site. And I'm also very surprised to hear about the involvement of many different academic departments of IIT Bombay, for the project. So this is completely amazing, to know. So talking more about photovoltaic research, which is the area of your interest, sir. What are the major challenges and opportunities in the Indian context?
Well, in the Indian context, of course, there are many challenges, also a lot of opportunities. India is today probably the second or third largest solar market in the world. If things go as we are planning, it may become really the largest solar market in the world, which means that the amount of solar deployment which we have will be more per year than any other country, except possibly China. The reason, obviously, is that we do have a lot of solar energy. It's very easy now to put up a solar plant, much easier than putting up a coal plant or a gas plant or, of course, a nuclear plant. Much easier, takes much less time, and obviously it is a cleaner energy than coal and gas, also less environmentally harmful than, for example, hydro, which is otherwise a clean energy, but you know that especially large hydro we need large dams, and the kind of long-term ecological problems do exist. Solar is well suited for India. We have actually a major commitment for really making sure that almost we put up somewhere. Today, the commitment is for 100 gigawatts of solar energy, but we are probably going to go up to 300 plus gigawatts of solar energy in the next 15 years or so. So it's a very large deployment. Looking at the opportunities and challenges for solar in India, there are certainly huge opportunities because solar energy is a very clean energy. It's a type of power which can be deployed very quickly and very easily. And India has a major commitment of today 100 gigawatts, but going up to 300 gigawatts over the next 15 years or so. So a lot of deployment of solar energy will certainly take place, which opens up a lot of opportunities for companies, major large companies, for deployment of 100 megawatt scale, utility scale power plants, but also opportunities for smaller companies which are doing small rooftop deployments and so on. There's also opportunity for manufacturing because 300 gigawatts of solar panels is really a lot of manufacturing which we need. So there's an opportunity for make in India and solar energy, the whole value chain from silicon going through to silicon solar cells, to panels, to the power electronics, to all of the other parts of the solar system which are required. A huge opportunity for this very large market which we will have in India. Obviously, there are challenges as well. One of the challenges will be to be able to build a full ecosystem where you are able to do manufacturing across the value chain. And the ecosystem is required because that's really how you would be able to get the cost down to a sufficient level. Another challenge which we are seeing, and this is something we've been involved with, is that the hot and humid climates of India actually pose a significant reliability challenge for the solar panels. Unlike a microelectronics chip, which needs to last only 8 to 10 years, the solar panels, once deployed, are expected to last for 25 to 30 years. And out there in the harsh environments of desert-like conditions or very tropical humid conditions. So that is a challenge, and we need to work towards really, firstly, making sure that we have good quality modules, and secondly, to ensure that the newer types of modules that we make are of good quality.
Sir, I know that you are interested in perovskite solar cells. So do these cells have a lot of potential for India in particular?
Well, I have some interest in perovskites, not really in the material, although at IIT Bombay, we do have several groups working on perovskite solar cells. And these are relatively recent types of solar cells, which people believe might replace silicon. I'm not very sure about that, but perovskites certainly are very interesting materials. And one of the ways in which I believe perovskites will become important going forward is that we can actually combine perovskite and silicon to make what are known as tandem solar cells. So these are perovskite on silicon solar cells. And the advantage is that both the perovskite and the silicon capture slightly different parts of the spectrum of the solar spectrum. And therefore, you can actually get more efficient solar cells if you have a perovskite on silicon tandem solar cell.
Sir, I saw a YouTube video of a talk that you gave at IIT Gandhinagar on this topic. And one of the important points in that talk you mentioned is about the microcracks generated through transportation and installation, which can be an important source of power degradation. So, would you have any broad set of recommendations on how to prevent these microcracks and how to deal with them when they arise?
Yes, so this is now going back to silicon solar cells, and the silicon, of course, is made on a single crystal silicon. But very often what happens is that during either the processing or later, cracks develop. And when these cracks develop in the silicon wafer, you can have power loss. Eventually, you may actually see significant power loss. In fact, we started seeing this, we have this very interesting thing called the All India Survey of Photovoltaic Module Reliability. Our team goes out and really has visited solar plants all over the country, all the way from Ladakh and right down to Kerala and Tamil Nadu, looking at how the solar cells, how the modules are performing in these different parts of India. That's where we started seeing that many of these cells appear to have cracks. And we started looking at where do these cracks come from. So we see that cracks appear to be a problem in India, especially, but also, of course, people have seen them in other parts of the world as well. And there are 2 or 3 reasons for this. One is that the transportation of the solar modules to these remote sites where the utility scale power plants, solar power plants are coming up, it's a very rough ride, and there's a lot of bouncing around of the panels, and we are pretty sure that that's where part of the cracks are arising. And the other thing is that even during the installation procedure, it's not often very carefully done, because again, you need very well-trained manpower to set up the modules, and this is not always available easily, especially when we're looking at small installations on rooftops and so on. So that's another cause for the generation of cracks. So these are 2 of the reasons. One of my colleagues here is now looking at how can we prevent, or what is the best way of packaging solar panels so as to minimize crack development during transportation. So as you can see, it's going very far away from semiconductors. We're really now looking at all kinds of other aspects. And when you look at a real life problem like deployment of solar energy, you have to worry not only about semiconductors, which becomes only one of the many, many problems which you will encounter.
Sir, one of the very exciting points you made in that talk at IIT Gandhinagar was about the challenge in cleaning, solar cells and the possibility of using robotics to do this cleaning. Would you like to talk a little more about it, sir?
I can just mention, yes, that this is a problem. And again, one of our teams at the National Center for Photovoltaic Research and Education is actually looking at soiling and cleaning of modules. It turns out that soiling, which is essentially dust settling on the solar panel, you think of it as a very trivial problem which every housewife in India is familiar with, but actually it turns out to be quite a complex problem, and a lot of technology can be brought into bear to develop anti-soiling coatings and to really understand how the soiling takes place, what's the process of soiling, what's the optimum frequency of cleaning. You don't want to clean it too often because then the surface gets abraded and that results in its own problems. Obviously, you don't want to have too much dust settling. That causes a problem. What kind of cleaning do you do? Is water cleaning good, or is a dry cleaning better? Remember that a lot of our modules are, being put up, being put up in areas like Rajasthan, where the availability of water is really, it's quite a problem. So water cleaning, although otherwise good, but wastes a lot of water. It's not easy to get good quality water. What's the quality of the water which you should use? Because that itself will produce problems on the glass. So cleaning turns out to be really quite a major issue. Robotic cleaning is being tried in various places, but it's not been as successful as we had hoped. But let's see, at some point it has to become automated, because as we see these huge plants, 100 megawatt plus plants coming up, it's not really possible to do a manual cleaning, which is typically what people have been doing so far. And for India, of course, it's especially a problem which does not exist in many other countries, where the dust problem is not as severe.
So is it ever conceivable in the future that we might one day not have a grid simply because we might have rooftop solar installations everywhere?
It is possible. In fact, one of my colleagues here, Professor Chetan Solanki, is really been kind of working towards that. It is possible in the sense, at least, that our reliance on very large power plants may diminish. We may have a lot of smaller power plants, including solar power plants, all of which kind of connect up together. Whether or not we will completely get rid of the grid, I am not sure. I don't think that will happen. What will happen, I think, is we'll have a multiplicity of sources, including solar, feeding into the grid. And there will be situations in which you can do without the grid also.
I understand. Sir, your teaching has been a great source of inspiration for us as students. And apart from microelectronics, one of the things that we as students have learned from you is how to communicate and how to be polite in each communication. When I was an undergraduate student, there was this instance in your class of a student sleeping in the very first bench. And the way you spoke to him about the inappropriateness of his behavior in a very polite and a firm way kind of fascinated our entire class. And we always wondered how you were able to communicate something so politely and yet so firmly. So my question was about your communication skills. You earlier mentioned of a very influential English teacher in school in the early part of your life. So do you think that this English teacher might have contributed in some way to these communication skills?
Yeah, I mean, it's possible. I can't say that I see any direct influence, but yes, it's always possible. By the way, Vivek, this example which you have quoted, I must have just been in a good mood that day, because there have been cases where when I've seen this happen, I have also been quite angry with the students. So, I think it depends very often on the external situation and how you woke up in the morning and things like that.
Sir, given your numerous awards and recognitions, which of these have given you the most amount of satisfaction in your career?
So, Vivek, firstly, awards are really not that important because they're usually an acknowledgement of something which, anyway, you probably have had derived a lot of happiness from doing. Otherwise, you would never have spent that much time doing it. But anyway, since you've asked this question, one of the awards, of course, was the Lifetime Achievement Award from IIT Bombay, which was naturally I was very happy to receive, very gratifying, because coming from the place where, of course, firstly, I was a student here and then really spent almost all of my professional years here. So in that sense, it was a very good acknowledgement, and I was very happy to receive that award.
That's great to hear, sir. Sir, you've been the Deputy Director of IIT Bombay and also have been Head of Department of Electrical Engineering. How have these experiences been, and how do you look back, at this phase of your careers?
Well, the head of department was quite long ago, and I don't remember, frankly, too much about it. But let me talk about the deputy director, which was not that long back. It was from between 2006 to 2009. That was for me again an interesting interlude, and I was initially a bit reluctant to take it up, but Professor Mishra, who was then the director, kind of persuaded me. And I'm glad I did take it up because it really opened up my eyes to another aspect, another type of activity of IITs. For example, of course, I had been involved in the teaching and the research and some of the administrative work also as head of department and so on. But there were many aspects about the overall administration of IIT, not the departmental administration, but the main building, the activities in the main building. And I came to understand and realize what an important role everybody plays. Just to keep the IITs working, there are so many people who are not the people which the students see every day, not even people whom the faculty members see every day, but whose presence is really very important to make sure the whole IIT structure keeps functioning on a day-to-day basis. So I think that was a very important realization for me, and to see how committed many of these people are in the kind of work they do, and they also perform their duties in a very systematic manner. And really, at the end of the day, that's one of the important reasons the IITs are what they are today. Not only the students, not only the faculty, not only the research, but a lot of other people working in the background. And as DD, I could finally come to see and subsequently appreciate that.
Sir, your association with IIT Bombay started in the year 1964, so which is 56 years ago. And so you've seen the institute from the 1960s, until now. So how has the institute evolved, since the 60s, as you see it, sir?
Yeah, so Vivek, that's of course an interesting question, but also a difficult question to answer. The reason, of course, is that memory of what happened 56 years ago, and what happened a few years ago, the memory is different. but also more importantly, one looks at things from different perspectives. So in 64 to 69, I was, of course, seeing IITs from a student's perspective. After I joined back in the early 80s, I was looking at it from the perspective of a young faculty member. Later, I was looking at it from the perspective of a senior faculty member. Now I'm looking at it from the perspective of an emeritus professor. So perspectives also change, and that obviously also colors how you see the changes in the institute. Firstly, of course, I would say that the institute has grown in size tremendously. When I was a student here, I think there were probably about 1,500 students on campus. When I came back in 1981 as an assistant professor, there were about 2,000 or 2,500 students on campus. And today we know that there are somewhere around 11 or 12,000 students on campus. So the number of students has changed dramatically. Number of faculty has also increased, although not quite as much. I think it was probably about 300 in the times when I was a student, 400 or 500 when I was a young assistant professor, and probably about 600 or 700 today. The other obvious difference is that there was a lot more focus on teaching and less focus on research in the early years. And this is something which I certainly benefited from, because as an undergraduate student, to be taught well by teachers who were really focused on the teaching was a great benefit. But as we've moved along, that has changed. A lot more emphasis now on research without taking away emphasis from the teaching. I think we continue to be strong there. So that's another major change which has taken place. A third change, I would say, is that the campus has become a lot more crowded now, because number of students has increased. Obviously, the number of hostels has increased. The number of buildings overall has increased. So it's no longer the, what I used to think of as the open campus with a lot of open spaces, which I remember from the student days. That's not quite the way it is today. But maybe, these are all phases in the evolution of any large institution. I would also add that when we were students here, IITs and IIT Bombay also were very new things. Most people didn't know about it. Whereas today, when you say IIT, it's an instantly recognizable name, whether in India or even across the world. Whereas in those days, nobody knew about it at all. So in one way, it was very good. We were not, when we got into IIT, we didn't think we were the, world's best people, because it was just another college to go into. On the other hand, we obviously had to explain to people what is IIT. Oh, it's not ITI, which people knew about, but it's someplace out there in Powai. Where is Powai? So all of those things. So it had its pluses and minuses, being relatively an unknown kind of a place, which is not true today anymore.
So, what have your memories of Professor A.N. Chandorkar been? Because he has been your colleague for a very long time. And when I came to the 25th reunion of my batch at IIT Bombay, I was shocked to hear that he was no more. So, would you like to share your memories of Professor Chandorkar?
Yeah, sure. I'll be happy to, because we worked quite closely together for many years. I joined the electrical engineering department as an assistant professor in 1981. I think Professor Chandorkar joined in probably 1983. And that was very good for me, because we were both working on semiconductors and working on MOS. Even Professor Chandorkar, one of his major interests was MOS. So together we could actually start working together. We could start working on several aspects. And one of the first projects which we took up was the so-called microelectronics project, where we got a lot of, in those years, very good equipment to start some of the experimental work. We were joined, incidentally, in probably 1984 or thereabouts by Professor Rakesh Lal. So then the three of us actually, for almost the next couple of decades, or at least the next 15 years or so, we worked quite a lot together on various aspects of semiconductors, on MOS and so on. Incidentally, in the early years, the technology of semiconductors, the technology of MOS, and the design aspects using MOS and CMOS were quite integrated. And both of us, both Professor Chandorkar and I, used to teach courses in both the physics and technology as well as the design. However, as things developed, I continued to focus more on the physics and technology, and especially the reliability and so on. Professor Chandorkar eventually started focusing a lot more on the design aspects. And then by, I think, around the 2000s or so, he was almost entirely doing design, especially analog design, whereas I was really doing more reliability. And then later on, of course, moving into photovoltaics. So at some point along there, we did not interact technically that much, although, of course, obviously, I still had some interest in design, and he had obviously some interest in the technology and the physics. So we did continue to have a lot of interaction together. We both incidentally lived also for many years in the same housing on campus. So that was another reason why we were very close to each other.
Sir, would you have a message to students and IIT Bombay alumni watching this video?
Well, no, my only message really will be that all of you, of course, have, I'm sure, done very well after you've graduated from IIT. And the very interesting thing about all of the students, alumni, as well as others, is that you have, taken up careers in many different in many different areas, whether technical, some are in various other things. Some of you are researchers, some of you have gone on into management. I know a lot of you are in the financial areas. So whatever you're doing, I'm sure you're doing well. My good wishes to you. My only message to you would be that, when you do come to Mumbai, I know many of you live in Mumbai also, but do visit us at IIT. Many of us will be very happy to see you again. Please also stay in touch with us, by email, various other ways to stay in touch. It's always a pleasure to hear from students. So I'll look forward to hearing from many of you. And whenever you're here, drop in and say hello in person.
Sir, I now speak on behalf of all my classmates of the EE 1992 class. Sir, we are very grateful to you, sir, for teaching, inspiring us, and motivating us at such a young age. Thank you very much, sir. We learned microelectronics and also many other things such as communication from you, sir. So, and the things that you have taught us have been very useful for our lives. Thank you very much, sir.
Thank you. Thanks, Vivek. Thanks for giving me this opportunity to talk with you, and also through you to a lot of your batchmates.
So thank you very much, sir. It's been really a delight to be able to talk to you and kind of revisit the memories of me being a BTech student at IIT Bombay. So it was really very nice. Thank you very much, sir.
Thank you. Bye.